Welcome back to Nature of Code in Rust and GGEZ. In this video, we're going to be going over example 1.3, vector subtraction. And here we're going to be creating basically just a screen with a line from the center of the window to wherever the mouse is pointing. And we can see here the code for this is pretty simple, although we're going to want to implement sub so we don't have to have a method like this for us. So let's go ahead and get started. There's a little bit of interesting math, especially with this translate here. So I'll explain what we're doing as we're doing it. So let's go ahead and get ourselves started. So we're going to head on over to the library. I've already copied over the template, which includes that vector structure that we have previously. So what do we need here? So looks like we're going to have to grab our mouse location. We need to know the center location of where we're at, and then we can do our subtraction. And then we're going to get the lines and then update our mesh. So to begin with, let's go ahead and store a mesh here. So we're going to have a mesh. Let's have that be an option with a mesh inside. And then we're going to build that out based upon the lines, like the line that we create. Now, here what's really interesting in this example is we're creating a line from 0, 0, the upper right, to wherever the mouse is. So we can do that pretty easily. Here in update, we're going to get the coordinates of the mouse. So let our mouse position equals GGZ input mouse position, hand it the context, and that's going to give us a structure, a mint location or a point, which is an X and Y. So we're going to convert that into a vector right away. So let's see, mouse position. So that's going to be our mouse location equals our vector 2 new mouse position X, mouse position dot Y. All right, so now we have an actual vector 2. This is an F32. It's going to figure that out pretty quickly for us. We do have those using generics. So if you haven't seen the video for how we're using generics, then I highly recommend that you take a look into that. Oh, we do have an error here. Let's go ahead and get that going for us. Our mesh. Okay. Now, then we're going to have, okay, so we need our mouse location. We need the center of the screen. We can also grab this out here using a context. So let width height equal to graphics drawable size, context in it. Okay, so now we have a width and a height, which means we can now get a center location. And that's going to be our width divided by 2 and our height divided by 2. Okay, so now we have a mouse location, which is a vector 2, and a center location, which is a vector 2. What's next? We're going to subtract the mouse from the center. What we would really like to be able to do is say, well, first of all, we need to be able to mutate mouse location. So mute this. We want to be able to say mouse location minus equals center location. That's what we want to be able to do. But you notice that we don't have a sub assign. So let's go ahead and update that for ourselves. So if we remember, this is in utilities, there is a vector 2, and we can go ahead and implement. So impl t sub assign for vector 2 t, Now we do have to have this where, so where t is a num that also implements copy and sub assign. We'll implement our missing members, and here we go. So what do we want to do here? For subtraction assign with a vector, it's just going to be the I minus equals, which is exactly the same thing that we see with the add assign, just the opposite. So self.x minus equals right hand side dot x. All right, there we go. If we come back to our update, everything is happy. And so now we have our mouse location. So we can use this to create the points that we're going to create our mesh with. So let's go ahead and create points. The points is going to be an array. And what's really interesting here is that this has the line starts at 0, 0, and then goes to where our mouse location is. So we're going to do the exact same thing here. 0, 0, and 0, 0 is the first point. And for the second one, it's going to be the mouse location to array. And this is going to allow us now to create our mesh. So do self.mesh equals sum. I have a mesh builder. Dot line. This is going to be a reference to the points. Width, let's make this 2.0 to try to ensure that you can see it on the screen. And our color, we'll just make you white. We need to be question mark, and then we can build you, and in the context, question mark that, and then we can do our semicolon. Oh, we don't need a question mark, semicolon here, just at the end. Okay, so that should assign mesh into self. And okay, so I think we're good now. So all we need to do is the draw down here. So let's go ahead, do a graphics draw. We'll throw in our context. We'll throw in a reference to self.mesh. Now, we do need to make sure we have the mesh. So let's go ahead and double check that right here. So if let sum mesh is equal to self.mesh, then we have the mesh, we can do our draw in here. And then we have our draw params. And we don't have to do anything there. And there we go. So if we have a mesh, we're going to do a draw. What are you upset about? You're not satisfied for the mesh. Well, you are a mesh. Oh, this wouldn't be a self.mesh. This would be, and we can just do this as a reference here. So now mesh is a reference to a mesh. Then it becomes a mesh. There we go. So now we have our mesh. If we draw this out and we actually run this, we're gonna get the line, but well, is it a line? It's not showing. We can't see it. So let's double check to make sure that everything is written correctly here. Because our points are starting from 0, 0, mouse location, like to the mouse location. Now we can, because we have that debug, we can actually debug where our points are. So we can do a debug macro and take a look at mouse location. Just sort of like see what this is. Make sure it's what we expect it to be. See, here's our numbers, and we can see, oh, look at that. We have to go way far away, and then we see it. But so things aren't exactly the way we want them to be. So that's a problem. Now, I do notice that they have this translate there, because it's not like this line is from the top left, and then we're subtracting. So actually the line is kind of going up and to the left, which we would expect if our line started at the middle of the screen to work. So we have to re-implement this translate here. So translate is pretty interesting. What we need to do is shift the entire canvas over so that 0, 0 point is in the center of the screen. So there is a really cool system that we can do here. So it's going to be graphics. Let's actually do this outside of the sum here. So we're going to do graphics, set, there's a transform here. Set transform, hand it the context, and then we have to hand it a transform. And transform is a draw param that's had like a 2 matrix. So it doesn't have any like colors or anything else like that. It's just for moving around the canvas essentially. So in here we're going to have, let's actually do this up here. Transform. Now, in order to do the transform, we are going to have the width and height. So let's get width, height. Okay, so now we can create our transform. Transform is going to be equal to a draw param, and we're going to add a destination onto it. Destinations are arrays. So for our x, we want to move over by half. So that's going to be our width divided by 2, and our height divided by 2. Okay, now in order to make it an actual transform, instead of just a draw param, we're going to do a 2 matrix on it. That gives us this column matrix, but that works with this set transform. Now at the very end, in order to have this like actually work for us, we have to do a apply transform. So we're going to do a graphics, apply transformations, hand it the context, handle the errors, and that should be good. Let's go ahead and try this now. Now our line is coming from the center of the screen, and that's perfectly fine. I'm going to go ahead and remove that debug line that we have up here. So what's happening here? Like, why is this interesting for us, and why would we care? This set transform is essentially shifting the entire canvas of where we're drawing over by whatever this draw param is. So we're saying shift over by half of the width. Well, that takes that center position from up here and moves it halfway over. So a 0, 0 becomes actually, 250 or 700 or whatever halfway the x is. And then our height, we do the same thing. So then it moves it down here into the very center of the screen. It's an easy way of moving things around without actually having to know where the center is. And that's it. That's example 1.3, vector subtraction. I'll thank you for watching, and I'll see you in the next video. Bye.